Hey guys, Miss DeLitto here. We're going to take a look at writing numbers in scientific notation. First of all, scientific notation is a way that we can express really big and really small numbers as a multiple power of 10. Anytime we express a number in scientific notation, it's important for our coefficient to be a value that is greater than or equal to 1, but less than 10. So for example, 4, 3.7, 2.95, but it cannot be 20.1 or 75. Those numbers are greater than 10. And it cannot be 0.25 or 0.5 because those numbers are not greater than or equal to 1. In some cases, we may have a number that's expressed as a multiple power of 10, like 74 times 10 to the 8th or 0.75 times 10 to the negative third, but they're not expressed in scientific notation. In these cases, we may need to change the coefficient, which will affect the exponent attached to our base of 10. So if we have to make our coefficient bigger, for example, in the 0.75 times 10 to the negative third, then our exponent will end up getting smaller. This is because we would need to multiply by 1 less power of 10 when we're trying to write that number out in standard form. If we need to make the coefficient smaller, like we would in the case of 74 times 10 to the 8th or 523 times 10 to the negative 8th, then our exponent will end up getting bigger because now we would need to multiply by 1 more power of 10 in order for us to get back to the original standard form value. If there is a situation like with 523 times 10 to the negative 8th where we would need to move the decimal place more than 1 space to make the coefficient greater than or equal to 1 but less than 10, then we would need to increase or decrease the exponent by the same amount. So let's put it into work and take a look at some examples. So for 74 times 10 to the 8th, we know that this value needs to have a coefficient that is greater than or equal to 1 but less than 10. Since 74 is greater than 10, that means we need to make that coefficient smaller. Right now, that decimal point is right here in 74. So to make this a value that's less than 10, we're going to move the decimal 1 place over to the left. So our coefficient would become 7.4. We still are going to multiply this by a power of 10. And in this case, because we made our coefficient smaller, we're going to need to multiply by 1 extra power of 10 to get to our original standard form. So we would need to increase our exponent by 1. So we would have 7.4 times 10 to the 9th. This would be equivalent to 74 times 10 to the 8th. However, now we're written in scientific notation. In our next example, 0.75 times 10 to the negative third, our coefficient is less than 1, and we need it to be greater than or equal to 1. So in order to change this and express it in scientific notation, we would need to move this decimal place 1 space over to the right, making our coefficient 7.5, and then we're going to multiply by a power of 10. When we think about our exponent, because we made this coefficient bigger, or now we're going to have to multiply by 1 less power of 10, since we made this bigger, our exponent will need to get smaller. With negatives, we want to be careful because a smaller exponent than negative 3 would be negative 4. So the more negative a value gets, the smaller the value is. So 0.75 times 10 to the negative third really should be 7.5 times 10 to the negative fourth in scientific notation. Let's take a look at one more example. So we have 523 times 10 to the negative eighth. In this case, again, our decimal is right at the end of this number. Because we need this value to be a number that's greater than or equal to 1 but less than 10, we need to move our decimal place 2 spaces over to the left, making this coefficient 5.23. And we're going to multiply by a power of 10. Because we moved our decimal 2 places to the right, we're going to need to change our exponent and increase or decrease by 2. In this case, because we made our coefficient smaller, our exponent needs to get bigger. So again, careful with our negatives. When we make negative 8 bigger once, we end up at negative 7. And we'll make it bigger twice because we moved our decimal 2 places, so we end up at 10 to the negative 6th. So we should end up with 5.23 times 10 to the negative 6th in our scientific notation. Again, as a general rule of thumb, if you make your coefficient bigger, your exponent will get smaller. And if you make your coefficient smaller, then your exponent is going to get bigger.